try and study the data first. Simple graph. Yeah, I'm sure all of you have understood the data. So let me explain what has been given here. He says 4 sets of people comprising of men and women are shown in the line graph. Answer the questions based on the information. So the blue line here talks about number of men, the red one talks about the number of women, and he's talking about 4 sets, set 1, 2, 3, 4, and easy values to pick, right? I mean 6 women, 10 men, 8 men, 5 women, 9 women, 3 men, 6 men, and what is this, 3 women. Easy, right? I mean 2, 4, 6, 8, 10, 12. So very simple data. We know the number of men and women in different sets, in 4 different sets here. Okay, let me present a couple of questions from this one here. So here's the first one. Try to solve this. See, the average time here is 103 seconds and the accuracy is 67%. So only 2 out of every 3 students have got it right, but average time spent is 103 seconds, which is close to 2 minutes. What is the question? From set 2, 5 persons are to be selected to form a committee so that at least 3 men are there on the committee. In how many ways can it be done? It's a simple question from permutations and combinations, but the data is in terms of a line graph. So nothing new about it. You should spend about 45 seconds to get the right answer. I don't know why does it take 103 seconds. 45 seconds is ideal time in my view. Let's see how many of you get the right answer. Ravneet Singh says it should be none of the above. So let's look at it now. He says from set 2, 5 persons are to be selected to form a committee so that at least 3 men are there on the committee. In how many ways can it be done? So basically he's talking about set 2. Set 2 is this. How many men? You see 8 men. 8 men. How many women? 5 women. Yeah, 8 men, and here we've got 5 women. So basically we have got a group of, now this becomes like a regular permutations and combinations question, right? We have got 8 men and 5 women. This is a group that we have. From this group, we have to form a committee of 5 persons, right? 5 persons are to be selected to form a committee. So committee of 5 persons needed, such that at least 3 men are there in the committee. At least 3 men. So there are 3 different cases. If you observe, 3 different cases. We can have 3 men, then there will be 2 women. Yeah, makes it 5-member committee. Or remember, what is the other way? 4 men plus 1 woman. Or what's the third way? 5 men and 0 women. You understand? So there are 3 different groups that can be formed. 3 different ways in which this can be done. We can choose 3 men with 2 women, 4 men with 1 woman, 5 men with 0 women. Remember, at least 3 men. So minimum 3 men. At least is what? Minimum 3 men have to be there in the group. So minimum 3 are always there, right? 3 or more than 3. So 3 or 4 or 5. Can we take 6 men? Well, we have got a group of 8 men. We can choose 6 of them. But remember, the committee should have only 5 persons. So stop at 5. And remember, in each case, the total has to be 5. 3 plus 2 is 5. 4 plus 1 is 5. 5 plus 0 is 5. Now, after this, it's like a regular process. Right? We total 8 men, 5 women. In how many ways can you choose 3 men and 2 women? In how many ways can this be done? 3 men out of 8. 8C3. Into. Plus means always into, right? I mean, and. Plus means not into, but this is like 3 men and 2 women. You understand? 3 men and 2 women. And 2 women. And means into. 2 women out of 5. 5C2. Or means what? Plus. This plus this one now. What is this? Similarly, 8C4 into 5C1. Or again is plus, right? How much is this? 8C5. And we don't need any women at all. So 5C0 is 1. That doesn't really matter, right? Into 5C0 you can say, but that's actually equal to 1. 5C0 is 1. Yeah. So simplify this, and this, then add all 3 of them to get the answer. Let's do the calculation quickly. Right? 8C3 into 5C2. So 8C3 is like 8 into 7 into 6 by 3 into 2 into 5C2 is 5 into 4 by 2. Yes, 6, 7, 8, 2, 3, 5. So 3 into 2, 6 gets cancelled. 2 goes here 2 times. So 8 into 7, 56. 56 into 10. 5 into 2, 10. 560. So this is 560. 560. Plus what's the other value? This one. 8C4. 8 into 7 into 6 into 5 by 4 into 3 into 2 into 1. So that's like 24. Into 5C1 you know is 5. Yes or no? 8C4 is 8 into 7 into 6 into 5. 4 factorial. Denominator will have 4 factorial, which is 24. 5C1 is 5. Simplify this now. Say 8 into 6 is 48. 48 by 24 will give you 2. Yeah. Now 7 into 5, 35. 2 into 5, 10. 35 into 10, 350. Something is wrong. Hold on. 2 into 7. Sorry, 8, 6, 48 by 24 is 2. 7, 5, 35. What is, yeah, so I think nothing is wrong, right? I mean, I was swayed by the responses that you have given. Most of you said 696 or 699. I was getting more than that, so I thought I'm wrong, but let me just complete it, see what happens. So 7 5 is 35, 35 into 10, 350. Maybe the answer is more than these two options. Yeah. Anyway, the last one, 8C5. 8C5 is like, 8C5 will be equal to 8C3. I mean, 8C5 is 8C3. Remember, right? NCR is equal to NCN minus R. NCR is equal to NC of N minus R. So 8C5 can be taken as 8C3, which is like 8 into 7 into 6 by 3 into 2. And 5C0 is 1. NC0 is always equal to 1. So 8 into 7, 56. That's it. Add these three values. 560 plus 350 is 910. 910 plus 56, 966. So I think 966 should be the answer, right? Option 1. Yeah. How did we get 696 or 699? 966, I guess, should be the answer. Check the calculation once again. Quickly. I mean, first of all, the concept has to be clear. Yeah, 560 plus 350 plus 56. Sorry, I got stuck here in the middle because I assumed that most of you would be correct. I thought it is a sitter and you can't be going wrong. Most of you mark 696 or 699. And after 560 and 350, I thought we have crossed the limit. So I thought something is wrong, but I think you guys were wrong. Answer is 966, option 1. Yeah. So Sagar, who is marked 699, is also wrong. 966 is the correct answer. Should we take up the next one? And why does it take 103 seconds? See, I have explained it, so it is taking so much of time, right? You just have to do those 3 different permutations. Venu Madhavi says calculations was wrong. That's why we got the wrong answer. Otherwise, the concept is clear. How does it help? Your concept should be clear. Your calculation should also be correct. You can't go wrong in your calculations. Sneha says, why is division by 13C5 not required? Because this is not probability. If it is about probability, then I will divide by 13C5. He's asking us to find out the number of ways in which it can be done. In how many ways can it be done? Number of ways is permutations or combinations, right? It's not probability. Probability, I mean, you will divide by the total number of cases when it is probability. Right? What is probability? Number of favorable cases by total number of cases. Number of ways in which you get the desired output divided by total number of outputs. In that case, you divide by 13C5 if probability is required. But here, it's not so. Okay. Let me take up one more question. Here's this will be the last question of the session. Very interesting. It's going to be lengthy. It will take at least 2 minutes for us to solve this. But I wanted to be clear with the concept first. So here's the question. Anil Kiran also had the same doubt. Anil and Sneha, I hope your confusion is cleared. So here's the next question. Next and the last one for the session today. Let's see if you get it right. He says all men in set 1 are numbered distinctly, 1, 2, 3 and so on. Then the number of ways in which 3 men and 3 women be selected and seated in a row such that in no case 2 men with even numbers sit together. Now guys, let me tell you, if you are not thorough with the concepts of permutations and combinations, you will not be able to understand this. Okay, so don't panic if you don't follow the explanation, right? I will not be discussing the basics here. For you to understand the basics, you have to watch our videos on permutations and combinations, right? We have classified all the we have lots of videos which have been classified into model 1, model 2, model 3 and so on, right? It teaches concepts one after the other. But if you are not thorough with the concept, then maybe it will be difficult to follow. Anyway, I'll leave you with this for 2 minutes or maybe 3 minutes. Try it out. I am not going to do the complete calculation anyway. I'll only explain you the concept. I mean the way you should solve it. You can play with the numbers later on. So we have, he's talking about set 1. Set 1, you know, has got 10 men and 6 women. So men are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and there are 6 women. Then we choose 3 men and 3 women and arrange them in a straight line. So in how many ways can that be done? Such that no 2 men with even numbers sit together. No 2 men with even numbers sit together. It's not a simple question. You have to consider all the possible cases and then try to get the answer. Skip this question. I think the best way to solve is to skip it. I am glad that you guys have mentioned that you will skip it, right? So I'm happy that you're able to follow the strategy, but anyway, from the understanding perspective, you should solve it. You should try it out. Yeah. While you may skip it in the exam, you should solve and see if you're getting the right answer. It'll help you, broaden your permutations and combination skills, right? Good. So can you quickly confirm who all have skipped it? All right, I'm sure it's going to be difficult for many of us. Let me explain you the solution, right? Again, I repeat, for you to be able to solve this question, you must be thorough with the concepts and things like how to arrange people when you want two particular persons to be together, how to arrange people when you want no two particular persons to be together, how to put men and women in alternate positions and stuff like that. So I'm assuming all of you are thorough with your basic concepts, right? With that assumption, let me solve it for you. So I'll again not solve it. You can do the calculation yourself. Only explain you the whole process. Now, here's the question. All men in set 1 are numbered distinctly, 1, 2, 3 and so on. Then the number of ways 3 men and 3 women be selected and seated in a row such that in no case 2 men with even numbers sit together. Yeah. So first of all, he's talking about set 1. How many people are there in set 1? We have got 10 men and 6 women. Total 16 people, right? 10 men and 6 women. Yeah. Now, all the men in this group are numbered distinctly, 1, 2, 3 and so on. So what are the 10 men? The 10 men are M1, M2, M3, M4 and so on up to M8, M9, M10. Yeah. And 6 women. There's no numbering involved in women here, right? Now the number of ways in which 3 men and 3 women be selected and seated. Selection and seating, selection and arrangement means it is a permutation case. Remember, the biggest confusion that most of the students have is it permutation or combination? This is a case of permutation. It is not combination. Combination means just selection. Permutation means selection and arrangement. So here he says we have to select 3 men and 3 women, right? 3 men and 3 women be selected and seated in a row such that, now here's the condition, such that in no case 2 men with even numbers sit together. Such that in no case 2 men with even numbers sit together. So there should be no case where 2 men with even numbers are sitting together. Now since he's talking about men with even numbers, right? What do you mean by men with even numbers? See, we've got 10 men, they've got numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So there are men with even numbers, 2, 4, 8, 10, men with odd numbers, 1, 3, 5, 7, 9, right? So basically, how many men with even numbers are there? 5. How many men with odd numbers? 5. How many women? 6. In case of women, there is no numbering involved, right? So 6 women altogether, men with even numbers 5, men with odd numbers 5, total men 10. Yeah. Now, what do we have to do? We have to find out those cases where we are selecting 6 people, 3 men and 3 women, and arranging them in a straight line in such a way that no 2 men with even numbers are sitting together. First of all, what is the total number of cases? Total number of ways. What is the total number of ways? I have to select 3 men. Total number of ways. Forget about any condition. No condition involved. Then how do you do it? I have to select 3 men out of 10. It can be done in 10C3 ways. And I have to select 3 women out of 6. It can be done in 63 ways. So I'll get 6 persons, 3 men and 3 women. 3 men out of 10 men, 3 women out of 6 women. So total I'll get 6 persons. These 6 persons have to be arranged in a straight line. It can be done in how many ways? 6 factorial ways. So the total number of ways in which you can arrange 3 men and 3 women out of 10 men and 6 women in a straight line is 10C3 into 6C3 into 6 factorial. This first 2 numbers indicate selection, this indicates arrangement. 6 people, 6 places, 6 factorial. Now from this total number of ways, you have to subtract those cases where 2 men with even numbers are sitting together. You have to subtract all those cases where 2 men with even numbers are sitting together. Okay. So let's look at that. Now understand, how many men are to be selected? 3 men are to be selected. Yes or no? We are selecting 3 men. Yeah. We are selecting 3 men, right? Let's say 1, 2 and 3 men. Okay. Now, What are the possibilities? All the 3 men can have odd numbers. Can we select all odd number men? Yes, possible. I can get M1, M5, M7. All 3 can be odd. I can select 2 odd and 1 even. I can select all 3 even. All even numbered men. Yes or no? All 3 men whom select can be even numbered men, right? M2, M6 and M8 have come. M2, M8 and M10 have come. All 3 are even numbered men. Right? All 3, 2 can be even numbered men and 1 can be odd numbered men. Yeah. Now, what do we want? We don't want 2 men with even numbers to sit together. Like for example, M2, M4 or M2, M8 or M4, M10. These cases, all these cases are to be excluded. These are not allowed. Men with even numbers should not be seated together. You see, all these are not allowed. Now, when can this happen? This will come into picture. Men with even numbers sitting together will come into picture if and only if I have more than 2 men with even numbers. Like for example, if I have all 3 odd men, will this be there at all? No. All 3 odd men is odd. Even men are not there at all. So this case doesn't really matter. Taking 3 odd men doesn't really matter. Right? Taking 2 odd and 1 even man also doesn't really matter, because here we have got only 1 even man. If there are 2 even men, only then this problem will come, right? Only then they can be together. But when there is only 1 man with even number, there is no chance that 2 men with even number are sitting together. So this also is ruled out. But the other 2 cases have to be considered. Case 3 and case 4. Right? Case 1, case 2, case 3 and case 4. Case 3 and case 4 have to be considered. Case 1 and case 2 are eliminated. Case 1 where we get all 3 odd men. Case 2 where we get 2 odd and 1 even men have to be eliminated. Not required. But case 3, you see, all 3 are even. When all the 3 are even men, when all the 3 are even numbered men, I mean, you know, it is possible that 2 even numbered men are together. Similarly, when 2 even numbered men and 1 odd numbered man is there, then also it's possible that these 2 even numbered men can come together. Yeah. Yeah. So total number of ways. So basically, if I now from total number of ways, if I subtract results of case 3 and case 4, I'll get the required answer. Right? So let's look at case 4 now. Results of case 4. Output of case 4. Output of case 4. Yeah. What happens? I want 2 even men. In this case, we want 2 even men and 1 odd man. 1 odd man. And of course 3 women. Now in how many ways can you do the selection in the first place? In how many ways can you select? See, I want 2 even men. Total how many even men? 5 even men. Right? So 5C2. And 1 odd man. 5C1. You're able to follow? 5C2 into 5C1. Yeah? Into 6C3. Not plus, into. Sorry. Yeah? We want 2 even men. So 5 even men, select 2. 5C2 ways. I want 1 odd man. So from 5 odd men, I'll select 1 odd man. 5C1 ways. And we want 3 women. 3 women are even needed, right? 3 men and 3 women. So 3 men have come. Now 3 women. Out of how many women? 6 women. 63 ways. 63 ways. So this is the selection. The selection part is done. We have selected 2 odd men, or sorry, 2 even men, 1 odd man, and 3 women. Now the arrangement has to be done. In how many ways can they be arranged? In how many ways can they be arranged such that the 2 even men are together? Such that the 2 even men are together. Now you have to go for those cases. Remember, like for example, we have to arrange the letters of the word, let's say number. In how many ways can you arrange the letters of the word number such that the 2 vowels are together? Such that the 2 vowels U and E are together. What do? We consider the 2 vowels to be 1 unit. There are 6 letters. 6 letters can be arranged in 6 factorial ways. But then what do? We consider the letters U and E to be 1 unit only. Only 1 letter. Since they are always to be together, right? So consider them as 1 unit and then do the arrangement. And then you will get the required answer where the 2 letters are together. So here we want the 2 even men to be together. See, how many people have been selected? 6 people have been selected, right? 2 even men, 1 odd man, 3 women. 6 people have been selected. So let me give you an example, right? I think I need some space. I'll clear this part here. Yeah. What should I clear? Yeah, let me explain you. So how do you do the arrangement? So let's say we have got ME1, M odd, and 3 women, W1, W2, W3. Okay, with respect to women, there is no condition. Now I want all the even men to be together. See, we are going to subtract these cases. From total number of cases, we are going to subtract output of C4 and output of C3. So what do? If I have to find out in how many ways can the 2 even men be together, I'll consider this to be one person. Actually, there are 6 persons, 1, 2, 3, 4, 5, 6, but I'll consider this to be one person. So 1, 2, 3, 4, 5. There are 5 persons. 5 persons can be arranged in how many ways? 5 factorial ways. 5 persons can be arranged in how many ways? 5 factorial ways. And internally, these 2 men can be arranged in how many ways? 2 factorial ways. Because these are 2 even men, right? So even 1 and even 2. Even number 1 and even number 2. So it can be even number 1 followed by even number 2, or even number 2 followed by even number 1. So this will give me the number of cases where in case 4, when we have selected 2 even men and 1 odd man, all the 2 even men are together. Both the even men are together. So when both the even men are together, we consider it to be 1 unit only. So total 5 units can be arranged in 5 factorial ways. Internally, the even men can be swapped in 2 ways. So 2 factorial. So this will give you the required output of C4. Yeah, this gives the required output of C4. Now what do you have to do? Find out the output for C3. We have found the total number of ways in which all these men and women can be arranged. Now we have found the output of C4, right, where we have got 2 even men and 1 odd men. Now look at the output of C3. Output of C3. From total you have to subtract these 2, right? Output of C3. What will be the output of C3? Remember, we want 3 even men. We want 3 even men. In how many ways can you select? I can select 3 even men in 5 even men, right? So we can do it in 5 C3 ways. Sorry, this is going to be a little complex to understand if you are not thorough with the concepts, but let me explain. 5 C3 ways into 6 C3. What is this? The number of ways in which I can select 3 even men, the number of ways in which I can select 3 women. Now these 3 even men and 3 women can be arranged in how many ways? Total 6 factorial ways. Now from this, I am going to subtract those cases where 2 men are together. See, basically we don't, now this time what has happened in this case, all the 3 men that we have selected are even. All the 3 men that we have selected are even. Yeah. So we have got 3 even men. Right? It's like this: ME1, ME2, ME3, and then 3 women, W1, W2, and W3. We don't want any of these 2 even men to be together. So how do we do that? Total number of ways of arranging these 6 people is 5C3 into 6C3 into 6 factorial. From these ways, I am going to subtract all those ways where the 2 even men are together. Yes or no? Where the 2 even men are together. How do you subtract that? See, selection is again same 5C3 into 6C3 only. 5C3 into 6C3. But the arrangement is as follows. What do? Whenever you don't want any 2 even men, whenever you don't want any 2 units to be together, first arrange the other. So this is again like that, no? In how many ways can you arrange the letters of the word number such that no 2 consonants are together or no 2 vowels are together? You don't want any consonant or any vowel to be together. So what do? If I don't want the vowels to be together, I'll first arrange the consonants. And then in the gaps, I'll arrange the vowels. If I don't want the consonants to be together, we'll first arrange the vowels and then arrange the consonants in the gaps. Similarly here, we don't want the men to be together. No 2 men should be together. So we'll first arrange the women. So 3 women can be arranged in how many ways? W1, W2, W3. These 3 women can be arranged in 3 factorial ways. 3 factorial ways. Now between women, how many places do we have? 1, 2, 3, 4. Remember, these are the 4 places which can be occupied by these 3 men. These 3 men will choose any of these 4 places, any 3 of these 4 places, and then arrange themselves there. This is a very, very important concept. I am assuming you are thorough with the concept there. If not, go through the TalentSprint's online video of permutations and combinations. First, arrange the women. 3 women can be arranged in 3 factorial ways. Now, in the gaps, total how many gaps are there? 1, 2, 3, 4. The 3 men can take any of these 4 positions. And you take any of these 3 positions out of these 4, you will always find that men are separated. See, this, the 3 men are separated. This, and this, again the 3 men are separated. You're getting it? So 4 choices, but only 3 required, right? So it can be done in 4P3 ways. Or 4C3 into 3 factorial, which is also 4P3. This is the output. This is the output for C3. Now the required answer, I'll tell you. The required answer will be equal to, if I say this is X, this is Y, and this is Z, the required answer is X minus Y minus Z. Do the calculation yourself, enjoy. One of these 5 options will be the correct answer. But like you all have decided in the beginning itself, the best way to solve this question is to skip it. So like I've always said, out of 5 questions in data interpretation, 1 can be real complex. This is a real complex one. Skip and just go to the next one. Hearing it, skip and go to the next one. I'm sure many of you are confused, and I'm not going to clear that confusion myself. I want you to try it yourself, understand the use cases, and then simplify to see what the answer is. What are we doing in a summary? To summarize, we have found the total number of ways in which 3 men and 3 women can be selected and can be arranged. 10C3 into 63 into 6 factorial. I want to subtract those cases where 2 even men can come together. Now 2 even men have to come together, meaning first of all I should have 2 even men. Now there are 2 ways. I can have all the 3 even men, or 2 even men and 1 odd man. So when all 2 even men and 1 odd man are there, selection of 2 even men can be done in 5C2 ways. Selection of 1 odd man can be done in 5C1 ways. Selection of 3 women can be done in 63 ways. We want both the 2 even men to be together. So that can be done in, if I consider both the 2 even men to be 1 unit. So total 5 persons, 5 factorial, internal arrangement 2 factorial. Remember, this will be subtracted from total cases to get the desired output. Output of C3. We are trying to find out all those cases where the even men can be together. Yeah. So 5C3, 3 even men, 63, 3 women. Arrangement can be done in 6 factorial ways. From this we are going to subtract all the cases where yeah, we're going to subtract all the cases where the men are separated. So the difference will give me the cases where the men are together, right? So now total number of ways minus these 2 cases will give you the required answer. I mean, try and understand. I'm sure you'll be able to follow it. It is confusing. It is lengthy. Skipping is the best way to solve it.